everyone, let's take a little bit of a deeper dive into functions and seeing how the domain can actually be restricted when we're trying to model these after real life scenarios. Okay, before we get into that, let's just cover a couple basic things about functions. Let's take a look. All right, so we're considering the function f of x equals x squared plus 1. We want to find the value of f of 2. So what this means is that 2 is part of our domain. 2 is our input, and we want to know what f of 2 is, meaning we want to know what the function is going to spit out when we put 2 in as an input. And while the function notation might look a little bit different, it's kind of the same thing that we've been doing for quite a while. And also, a real important note, f of x does not mean f times x. Not at all. So let's make sure that we're doing this appropriately. So for part A, when we want to find the value of f of 2, we simply just plug it in for x. Because you'll notice that we have a 2 right here, and here we have an x. So here we have an x, so kind of makes sense that we would replace that 2 with an x. Okay. And one thing I want to make sure that is, something that I always kind of harp on and on about, make sure you're using parentheses, because whenever you're squaring a negative number, one of the most common mistakes I see is that these parentheses aren't there and you're going to get the wrong answer. So make sure that whatever your value is that you're inputting into the function, you're putting in parentheses into your calculator. Or if you're doing it by head, not that bad of a thing to look down on and see the correct way to write it. So I would have 2 squared, that's 4, I would have 5. So f of 2 is 5. And if I wanted to write that as a coordinate pair, I would have 2, 5. I have my input 2, my output 5. My x coordinate 2, my y coordinate 5. All right, so now let's take a look at b, which is really just the image of -1. So what that means is kind of the same thing we just did. It's just using slightly different vocabulary. What it wants us to do is it wants us to take -1, and then it wants us to basically put it into this function, x squared plus 1, and then get out our image and see what we can get out of it. So what exactly is that? Another way of thinking about this, kind of similar to what we just did with A, is to write it as f of -1, because that's what we want. We want to input -1 into this function right here. We want to get out of it a value. So it would have -1, remember those parentheses, squared plus 1. So f of -1 would be equal to 1 plus 1, f of -1 equals 2. So the image of this is 2. The image of -1 is 2. So let me go ahead and erase this right here, place that with a 2. Now, if you did not put these parentheses, you would have -1 squared plus 1. What the calculator is going to do is it's actually going to do -1 squared. And that's going to give you 1 times 1, 1. But then it has this negative on the outside, so it's going to make your answer negative and you get 0. That's the wrong answer. So make sure you're using parentheses. I cannot stress that enough. Okay, and so now the question is asking us, hey, can we determine whether this point 526 actually lies on this graph? It's like saying, hey, given this input and this output that maybe you want to happen, or maybe you're wondering if it happens depending on the context of the question, how is that possible? Well, it's actually quite easy, because 5 is our input, 26 is our output. So if 26 is our output, that's going to be, well, what this whole equation is equal to. And we know that x squared plus 1 is the function that we're dealing with, and we're going to be putting into that the x coordinate, which is 5. So I want to know if 5 squared plus 1 is going to equal 26. And if that equation holds true, then it turns out that yes, this point will be on the function. So 26 does equal 26, so yes, 526 is on the graph, which means that if you put in a 5 into the function, you will get out a 26. And then if you put a 26 in for your output, you'll get 5 as your input. All right, that's simple. So let's talk about models. So a model really is just kind of where these linear functions and kind of a lot of mathematics is really, really, really useful in modeling real life scenarios, real life engineering problems, financial problems, pretty much anything that you can really think of in terms of the sciences. It's one of the greatest things to come out of mathematics, in my humble opinion. And in our context here, where we're going to keep it really simple, a model is really just an appropriate or suitable mathematical representation of some kind of situation that you're going to find yourself in, whatever it happens to be. So in this case, what we're trying to model is basically the price of a motorcycle after some years go by. And that kind of makes sense, because maybe you buy a motorcycle, you want to know how much it's going to cost. And then if you're given this curve, this cost curve, with your input as time, you can figure out how much time it's going to take for this motorcycle to become worthless. If you want this motorcycle to be sold at 50% of its original value, you can figure out how much time it can actually go by that you can own it before you have to sell it. There's a lot of different things that you can do with this. So now let us start with the equation. The price as a function of time, P of t, is equal to 15,000 minus 2,500 times t, standard linear equation. We have a y-intercept and a slope. And we know that our domain is going to be limited to 0 to 6. How do I know that's my domain? Well, because t is my input variable, and then I'm given my t restriction right here. That's how I know. And then the price as a function of time, P of t, is going to be my output. So price will be my output, time will be my input. Now let's take the independent and the dependent variable. Perhaps you remember this. Independent variable is basically your input. That's an easy way for me to remember it. Whatever you're inputting into the function is your independent variable. Those first two letters kind of match up nicely on those two words. Go English. Independent variable here is my input, and I'm inputting time. So my independent is going to be time. My dependent is what the function, you input a value into the function, and then that's what your overall value that spits out is depending on. So your dependent in this case is going to be your output, which is going to be the price. And again, I know that because I have a t right here, and I have a t right here. That's going to be my domain, my input, and I P of t, the price, is going to be the output. It's what this whole thing equals to. So now let's find P of 0 and figure out what that means. So again, just like our last example, I just put in 0 as my input. So if I have P of 0, that's going to be equal to 15,000 minus 2,500 times 0. P of 0 is just going to equal 15,000. So what does that mean in the context of the problem? Instead of writing it out, I'm just going to tell you, but of course you'd have to write this out if you were going over it on an exam. What this means is that this is the price of the motorcycle when 0 years have gone by. Another way of saying that is that you essentially haven't really purchased this motorcycle yet. You haven't owned it for any amount of time. Time is 0. So this is what we call the initial price of the motorcycle. This is the price of the motorcycle that you see on the lot. It's what the price tag, that MSRP sticker thing, is going to say. It's going to say, hey, right off the bat, it's going to be $15,000 before you own it because 0 years have gone by, and that's the price of the motorcycle. So it's just the initial price, plain and simple. Now let's find the price of the motorcycle 1.5 years after purchase. Okay, so maybe you bought in the summer, you went through a whole year, and now it's that following winter after a year and a half. So I would just plug in P of 1.5 is equal to 15,000 minus 2,500, 1.5. And your calculator, and you're going to find that the price after 1.5 years is going to be $11,250. That's what the motorcycle is worth after a year and a half have gone by, about 18 months. Not about, it is 18 months, 1.5 years. So now let's go ahead and let's find the value of t for which this whole function is going to be 6,250. So we're kind of going the opposite direction because before we would input something to this equation and get an output out. We would put in time and get out a price. But now we want to say, hey, this is the price. I want to know how much time it's going to take to get there. And so in this case, well, P of t is going to be equal to, and I'm going to make this smaller. Okay, so P of t is going to be 6,250. So I'm going to have 6,250, my P of t, and that is going to equal my equation, which in this case is 15,000 minus 2,500 t. So now through some very basic algebra, you can go ahead and solve this. A lot of calculators will solve this for you, but I could have 6,250 minus 15,000 is equal to negative 2,500 t, and I can go ahead and divide each side by negative 2,500. So you'll find that the answer is 3.5 years. So after 3.5 years, this is now going to be equal to 6,250. So it's different than our last problem because we put it in a value, an input 1.5, and we got out the price. In this case, we're telling you what the price is, and we want to figure out the time. So in one of them, a little bit more algebra is required, but same basic steps to solving. Now, I want to comment on the case t equals 6. So another way of thinking about that is, hey, what actually happens when t equals 6? Why is that significant? Why is the problem wanting me to do that? So let's go ahead and figure out, well, when t is 6, what happens? So P of 6 is going to be equal to 15,000 minus 2,500 times 6. If you put that in your calculator, you're going to find something that P of 6 is equal to 0. What this means is that after 6 years have gone by, your motorcycle is now, unfortunately, worthless. You can't sell it for any money. After 6 years, nobody wants to buy it. That's what that means. You put in a 6 for the years into the cost function. You figured out that at 0, that is the longest amount of time that you could possibly own this motorcycle and still sell it back for something. It has to be less than 6 years. Can't be 6 or more. Sorry about that. Bummer. So let's go ahead and sketch the graph of this function. And one of the easiest ways to do it is, well, by looking at the answers that we have. Because again, independent is what we're putting into the function, and that's going to be our x-axis, which in this case is going to be time in years. And up here, we're going to have price in terms of dollars, because price is our output, our y, our input is time, t. So when we put in 0 for years, as we did in part B right here, find the value p of 0. So we put in 0 for years. Our value of the motorcycle, our initial price, was 15,000. So let me go ahead and actually mark that. Let me mark this as 15,000. Draw a big old circle there. And we're actually just given another really easy point with this part E. Comment on the case where t equals 6. Well, when t equals 6, price was 0, meaning that price is going to go all the way down to here where it's 0, and that's going to happen at t equals 6 years. So again, this is not a super official looking graph. It's much more of a sketch, and that's because the problem, well, it asked me for a sketch. And so what I did is I just showed you, hey, at 0 years, this thing is going to be worth 15,000, and it's going to decline in value constantly over the course of 6 years until it gets to 6, and then now it's worth nothing. And that actually makes this domain restriction make a lot of sense, because if we are restricting this between 0 and 6 years, well, you can't own a bike for negative years. That doesn't make sense logically, right? So it has to start at 0, and then you can't really, you can't sell a bike back for negative dollars. I suppose there's a weird theoretical situation where you pay someone to take your bike. It sounds a little sketchy, like you're trying to get rid of it a little bit too hard. But in this circumstance where you just want to know what the value is for this bike and considering how long you can own it for, this domain makes perfect sense. And that's why we restricted it to 0 to 6 years, because you can't own a bike for less than 0 years, and then after 6 years, it's worth $0. All right. So I hope that helped shed a little bit of light on how we're going to use linear functions for modeling and how our domain restriction can be applied to a real world problem. Okay, hope you enjoyed that one, and I'll see you all in the next one. Take care.